right, so now we're going to use the definitions of the trigonometric functions that we learned the other day. Okay, so remember we have these reciprocal identities, and we talked about how cosecant is the reciprocal of sine, secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, so if you know the sine value, then you can find the cosecant by taking its reciprocal. So let's take a look at example 1 to see how that works. Alright, so we want to find cosine of theta, and we know that secant of theta equals 5/4. Well, the relationship between the two is that they are reciprocals, so the cosine of theta is just the reciprocal of 5/4, so it's 4/5. And that's it. Alright, so sine of theta, we want to find sine of theta if cosecant of theta is equal to negative square root of 5 over 2. Well, again, they're reciprocals, so the sine value for theta is going to be negative 2 over the square root of 5. But then we need to rationalize the denominator, so we're going to multiply by the square root of 5, and whatever we do in the denominator, we have to do in the numerator. So we get negative 2 times the square root of 5, and the square root of 5 times the square root of 5 is the square root of 25, or 5. And so that is your sine value, negative 2 square root of 5 over 5. All right, now let's take a look at the coordinate plane. All right, so here we have our y-axis and our x-axis, okay? And in the first quadrant, our x value is positive, y value is positive, and the r is positive. Now remember that r is the radius. So if you take a look over here, this is your r value, okay? So if we have a point here on the circle, and that point is x, y, then here's your x value, there's your y value, and the r is the radius. So remember that. R is the radius. Okay, now remember you always have a positive radius. You can't have a negative radius because the radius is the distance from the center for all the points on the circle. So having a negative radius doesn't make sense. All right, so here for the first quadrant, everything's positive, which means that all the function values are positive. Over in the second quadrant, remember that x value is negative. So anything with the x is going to be negative because you have one negative and two positives. Okay, so your sine and cosecant are positive, but now your cosine, your secant, your tangent, and your cotangent are all negative because they all have an x value in them. All right, and then in the third quadrant, now your x and your y are both negative. Again, your r is still positive. That's always positive. So now only your tangent and cotangent are positive because remember that they use x and y. So if you have a negative times or divided by a negative, then you're going to have a positive. Whereas with sine, it's y and r, so you have a positive and a negative. And with cosine, it's x and r, so you have a positive and a negative. So those would be negative. So the only positive functions are tangent and cotangent in the third quadrant. And then finally, we've got the fourth quadrant. Now we have a positive x, a negative y, and again, positive r. All right, so anything, well, not anything. So when you have an x value with the r value, that's positive. So cosine and secant are going to be positive. But then with sine, you have y and r, so you have a negative and a positive, so that's going to be negative. So your sine and your cosecant will be negative. And then tangent uses the x and the y, so you have a negative and a positive, so tangent and cotangent will be negative. So I've just shown you which functions are positive in each of the four quadrants. Okay, so now let's take a look at the ranges for possible values. Okay, we know that where we can have negatives and positives, but now we want to look at what is possible, okay? So now let's take a look at what sine is. Remember that sine of theta is y over r. Now let's take a look at our circle again, all right? Are we ever going to be able to have a y value that's larger than r? No, because all of the points are on the circle, and the r is the longest distance you could possibly have. Remember, in a right triangle, the hypotenuse is always the longest side. Okay, so the r always has to be bigger than the x or the y for that matter. So, I'll put that up here. R is always bigger than y. It can be equal to, though, and r is always greater than or equal to x. Because remember, if you have your r right here, well, let's say your r is right here, your x value is 1, and so is your r value, okay? Well, not 1, but it's r. Sorry. Your x value is r, it's the same as the radius, and your y value is 0. If you come up here, now your x value is 0, and your y is the same as r. All right, so remembering that the sine is y over r, okay? So you're going to have these values, and your smallest value for sine is going to be 0, because if y is 0, well, I'm sorry, not the smallest, but the y value here is 0 over r, so that's just going to give you 0. But as you move up here, your y value increases. And then as you get to the top, your y value is now the same as r, so that's going to be 1. So the highest possible value for sine is going to be 1. And then as you move down, your sine value gets smaller again and closer to 0. And then as you move down here, your sine value approaches -1, because down here you have an x value of 0, but now your y value is -r. Okay, so now you would have -r over r, which is -1, and that's the smallest possible value for sine. Okay, so again, your largest is up here, which makes sense because that's your highest y value, and your smallest is down here because that's your lowest y value. And then let's look at the same thing for the x values. Your largest is going to be over here, which again is r, so that's going to give you, remember that cosine is x over r. So if your largest x value is r, then r over r is 1. So the biggest possible value for cosine is going to be 1. And then over here, your smallest possible value for x is going to be -r. Okay, and that y value is 0. So you would have -r over r, which is -1. So you can't possibly have values for sine and cosine that are outside the limits of -1 and 1. So you wouldn't have -1.5 as a sine value, and you also wouldn't have 3 as a sine or a cosine value. All right, now let's take a look at tangent and cotangent. So you have tangent of theta, and that's y over x. Well, whenever you, no matter what x and y values you had, you could get any number, any real number is possible for tangent and cotangent. So, equal, and this is all real numbers. All right, and now let's take a look at the secant and the cosecant and their relationship to these other values. All right, well, if cosine is x over r, then remember your secant is r over x. So we'll put secant over here. Secant, do this, all right? So secant theta is r over x. Well, remember that r is always larger than x. So your number always has to be less than or equal to -1, because the highest possible value you can have here is -r. And then it gets smaller and smaller, and you know that when you have a small number in the denominator and a larger number in the numerator, then you have a number larger than 1, or less than -1 if it's a negative. So your secant values can only be less than or equal to -1, or greater than or equal to +1. And then the same thing is true with cosecant. Because it's the reciprocal of sine, it's going to be r over y. And so again, just like the x, the y value, the largest you can have is r, which would give you a 1. So the largest y value is going to be a 1. So as your y value gets smaller, then you have a larger number on the top and a smaller number on the bottom. So your numbers are going to be larger than 1. So cosecant is greater than or equal to -1 or +1. And then the smallest it can be is -r. So that gives you a -1. So this gives you the ranges for the possible ranges for the trig functions. Example number 2, identify the quadrant or quadrants of any angle that satisfies cosine theta is greater than 0 and tangent theta is less than 0. So let's look at our quadrants. Okay, here's 1, 2, 3, and 4. Now remember, cosine is x over r. Okay, so remember that r is always positive. So if we need cosine to be positive, we need the x value to be positive. Okay, so x is not positive in the second and third quadrants, but it is in the first and fourth. Okay, so that satisfies that one. Now let's take a look at tangent. Well, remember tangent of theta is equal to y over x. Okay, and we know that x is positive because cosine was positive. All right, and we need tangent of theta to be less than 0. So if the x is positive, the y has to be negative because the tangent is less than 0. And so since we already know we only have these two options, the fourth quadrant is the only place where both of these statements are true. Cosine of theta is greater than 0 and tangent of theta is less than 0. So our answer is going to be quadrant 4. Now let's take a look at example 3. Now here is where we want to look at our ranges for the trig values. Okay, so sine of theta is equal to square root of 2. Well, the square root of 2 is larger than 1, so that makes this impossible. It's impossible because the square root of 2 is greater than 1. And we know the sine value cannot be greater than 1. All right, tangent of 37.5, that's possible because tangent of theta can be any real number. Okay. Tangent of theta can be any real number, so as long as that didn't have an I with it, it's good. All right, and then secant of theta is equal to 0.8 or 0.8 or 4/5, however you want to look at that. Now remember your ranges. Can you have a secant value that is less than 1 and greater than -1? No, you can't. Okay, so this is impossible. And that's because the secant has to be greater than 1, or equal to, or it has to be less than or equal to -1. And so it's got to be on the outsides of those numbers. It can't be in between -1 and 1, and 0.8 is.